good afternoon, and very good afternoon. Hope you guys doing great, right? Yep, I hope so. Well, today's topic is really interesting, and it's about the starburst or star flare which you are getting from any lens. What happened was, a couple of days ago, I come to know about the very first image. Actually, not a couple of days ago, yesterday. Yeah, it was yesterday. Actually, it was yesterday night. Yep. So yesterday early morning. Yeah, yesterday early morning. So I have been sent by one image of from which was the very first image from James Webb Space Telescope, and when I looked into the image, uh, it hit me something really informative, and what it was all the tiny stars from which the image that James Webb took, all the tiny stars are having six flares, six specific flares, all of them. And now, when I saw the same image compared, with the Hubble telescope, which took the same image, those six flares were not there on those specific stars. So I saw them side by side and I was like, why we are having six flares of those pointy stars? And then I look into I start searching and then look into the construction of the James Webb Space Telescope, and it quickly hit me. It was obvious that the James Webb Telescope uh, creates six stars. And the reason is, as you are aware, that it contains of 18 mirrors. That one single mirror is hexagon. It has six sides. Six sides. One, two, three, four, five, six. So it has six sides, six edges each mirror. And there are 18 mirrors, so they realign those 18 mirrors to create image. So that James Webb is a reflective telescope, big reflective telescope, kind of. Yep. So each those mirrors are having six edges, which creates those six flares. Now, I'm pretty much sure that most of you are not aware of this, but if you are, by the way, each of the edge of that mirror is behaves exactly like the aperture blade inside your lens. So each blade reflect the amount of light in the two direction. When the light is hitting to an edge, it creates two pattern. Two, it splits the light into two direction. That's called diffraction. So in the lens, each aperture blade caused diffraction, which we all know that. Same phenomenon happened in the James Webb Telescope. Each side of the mirror creates diffraction. That's why six di- six uh, six edges, so it creates six flares. But that's not the point. The point was, actually, that was the main point, which I already tweeted about, and people are start responding, which is good. Um, but the question is how we are having these flares, and how they are created. Now, here is the interesting thing, and I really need you all guys to know about that, because this will help you in choosing the lens if you are a creative photographer, if you want to have the creative star flare in your image. So this information will help you in choosing the right lens. By the way, every company they make lenses with different uh, number of aperture blades. Telephoto lenses having different aperture blades, which are higher, 9 or 11, I don't know. Some wide angle lenses are having different aperture blades. The medium focal length are having different aperture blades, because they are all targeting for something creative, and that's why the number of aperture blades are different in each of these broader categories of lenses. But the question is how they are created. Now, this is the very simple thing which you all must know about that, which is, if you are having even number of blades, you are going to have same number of star flare or star burst. Now, for example, if you are having four aperture blade, so you're going to have four flares. if you are going to have 6 aperture blades, you are going to have 6 flares, which is exactly you noticed in James Webb Space Telescope. Yep, interesting, right? If you are having 8 blades, you are going to have 8 flares or 8 starburst. But what about the odd? What about 5 aperture blades, 7 aperture blades, or 9 aperture blades? Now, when it comes to, like I just said, if you are having even number of aperture blades, you are going to have same number of starburst or flare, same number of flare. But if you are going to have odd aperture blades, you are going to have double the starburst or flare. So if you are having 5 aperture blades, you are going to have 10 starburst or 10 flares. If you are going to have 7 aperture blades, you are going to have 14. Now how it works, why the even creates the same amount of starburst but the odd creates double the starburst. Now here, this is what I'm going to draw for you guys on my iPad screen, and I'm going to share with you, and then you will be able to understand how it works. Okay, let's get started. Let's get into the business. All right. Wait a second. All right. So here we go. So let's imagine you are having a lens. So this is the lens, right? This is the lens, and it has 4 aperture blades. All right. So this one, all right, sorry. So this one contains this. I'm highlighting each aperture blade with a specific color so you will understand what I mean to say, and how the even creates even and odd creates double the star flares. I'm going to draw this thing and you will understand. So this is number 1, this is number 2, this is number 3, and this is number 4. All right, so far so good. Now, like I just said, each flare, when the light hits on each plate, it splits into 2 directions. All right, so let's going to draw that thing, and let's start with the red. All right, so what happened is when the light hits to a red aperture plate, it splits into 2 directions like this. All right, I hope I drew it right. Right, okay, so it's like that. I'm going to draw this one a little more. Now wait a second, let me draw a little more precisely so you will understand. Alright, so the light is split in 2 directions. In the same way, when I created yellow, now let's draw with green. So the green will create one in this direction and one in this direction, and then blue, let's draw with blue. So blue will create this, and one is this, and then we have yellow. So yellow is this, one is this. So as you can see clearly that I'm having these basically these two cancel each other and these two cancel each other, and in this way I'm going to have 4 starburst for each side, which you can see. Yep, that's how even number of blades create even number of flares. Now what about the odd? So let's draw odd. So I'm going to have a lens which creates 5 blades. So it means that I have to differentiate with 5 colors, right? So let's draw. So first of all, I have to draw with cyan, so clear. Then I'm going to have red. So this is red. Then I'm going to have yellow. Then I'm going to draw with blue, and then I'm going to draw with green. So I have 6 aperture blade with 6 colors. Now I'm going to draw each of the flare and see how it goes. So this is one. Like I said, it creates 2 two direction. Then I'm going to draw with green. Then I'm going to draw with blue. Then I'm going to draw with yellow. Oh, sorry, yellow. And then I'm going to draw with red. So as you can see, we are going to have again, yep. So we are going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rays. See, now it's very much clear why the odd number of aperture blades creates double the star flare or sun flare, whereas the even creates equal, because in even one of the part of their rays cancel each other and the rest goes the other direction, which you can see. So same applies for 6, 7, 8, 9, 10, and 11, 12, 13, 14, and up to 18 aperture blades. I'm going to share with you on the screen. I have the whole list of aperture blades, and also called diaphragm blades, and their Sunstar rays or sunflare, the quantity, the number of rays they are creating. I'm going to share with you on the screen right now, as you can see. Yep, so that's it. And these are the list and the sources of the lenses you can go with, and you can go get those lenses and try to get the artistic effect out from those lenses. You know, when I first came across with 6 rays, and it immediately caught my attention, I was like, how can I get those 6 aperture blade lenses? But typically we are having 7 blades onwards, which creates a whole lot of starburst. But I want to make things more simple, which just like James Webb Hubble Telescope. And it, I was studying this thing for a very long time, but the moment I saw the James Webb image, and I was like, oh, it's because of the 6 sides of the mirror. That's why it's having 6 starbursts or star flare. So that study of mine helped me out in figuring out, and that's really great. I hope you like this video. It's just informative, like always, and I hope to see you guys in future with some other video with some new stuff. Till then, take care.